Hi everyone. So today we will learn about the Newton's law. Firstly, Sir Isaac Newton has discovered the first, second and third laws of motion. He introduced them in 1687 in his book named Principia Mathematica. These laws explain how objects move and how forces affect motion. So on the next slide, we will learn about how these three laws actually works.
Newton's first law of motion, also known as the law of inertia, stated that an object will remain at rest or move at a constant velocity unless acted upon by external force. What it means is, if an object is at rest, it will stay still. But if the object is moving, it keeps moving at the same direction at the same speed unless a net force acts upon it. For example, when a ball is staying still and no unbalanced force put into it, it will stay stationary. And for the next example, when a moving car stops quickly, your body will keep moving forward, and that's inertia.
Newton's second law basically state that is how object change emotion when force is applied. So in simple term, like for example, as you can see here, it's basically how a man can just from stop change to from running and to keep running further. This part is the Newton's second law. So what's the basic formula of it? So the basic formula is F equals to ma. Basically, F will be the force, mass will be m will be the mass, and a will be the acceleration. So going back to our example, like as we can see here, as the man increases acceleration, more force will be applied. So where can we see this apply on? And we can see this for car acceleration. Like for example, the mass of the car is 1,000 and it's going at a constant rate, right? So what if the car want to accelerate more? And when the guy press on the pedal, it will increase the acceleration. Hence, it will increase the force since acceleration is directly proportional to the force.
Now, let's talk about Newton's third law. Newton's third law of motion stated that for every action, there is an equal and opposite reaction, basically action-reaction pair. Let's take a look on the example. So we assume that this car is moving forward with zero acceleration. There is force acted on the car by the engine that causes the car to move forward, and since the net force is equal to zero, there is also frictional force that acted on the opposite direction. Another example is a book stationary on a table. We know that every object on Earth has weight, so weight is always pointing downward, W equal to mg, and to say stationary, there's also normal force which is equal in magnitude but in opposite direction to the weight itself. Therefore, it shows that in every action there is a reaction which causes the system is in equilibrium.